Welcome to week 7, day 3, part 2 of solving rational equations. So what we had discussed on day 1 of this week for part 1 was that a rational expression is not defined when your denominator is 0. And so what I've given you here is an additional example, just like the beginning of Monday's notes. And I've given you an equation, and I want to see if you guys can figure out which values of x could not be allowed for this proportion. So I want you to take a second and try to answer that real quick. And hopefully you are looking at the two denominators. And this denominator, this first denominator right here, you can't be allowed to plug in x is negative 5 because negative 5 plus 5 would put a 0 into that denominator. And this second denominator right here, x would not be allowed to be equal to negative 2 for the same reason. It would make that denominator 0. So negative 5 and negative 2 are the two excluded values for this proportion. Remember that when you're solving equations, you keep those excluded values in mind. And then if you end up generating either of those excluded values when you're solving, you throw it out from your solution set. Okay? And then bullet point number 1 is just a reminder that when you have a proportion, you simply cross multiply to solve. And that we had done that back in week 5. So once again, we are going to concentrate on the alternate kinds of equations and the alternate methods for solving. Remember that at any point you can pause the video and copy down anything you need to copy down. There is no expectation that you have printed these notes out. I'm just screen capturing to save time and make the videos shorter. Okay? So what we solved on day 1 were equations where we combined portions of the equation on one side or the other to create a proportion out of our equation. And then we could cross multiply to solve. Today, the method we're going to be practicing is what we call clearing the denominator, or eliminating the fractions in the equation. Okay? And we're going to do that by distributing the LCD for the fractions in the equation. Okay, so example number 1. Example number 1 is already set up as a proportion, but in this case, while you can cross multiply to solve, look at what would happen. As soon as you cross multiply this direction, you would have a quadratic times a linear. You would have r squared plus 1 times r plus 1, and you would create a cubic equation that you would then need to solve. So there are other options available to you. Okay, you do not have to cross multiply just because something is already set up as a proportion. So what we are going to do is this new method instead. So the first thing that we do is we look at our equation and we ask ourselves, what are the possible excluded values for this equation? Remember that r squared minus 1 is a difference of 2 squares. It does factor. It factors as r plus 1, r minus 1. Okay, and then this second denominator right here is already an r plus 1. So what that tells us is actually two things. The first thing that it tells us is it tells us that we have two excluded values, and they are positive or negative 1. So plus or minus 1 are the two excluded values. The other thing that it tells us is it tells us what our LCD is. Remember that the least common denominator is the denominator that will have all of the factors from the various denominators accounted for but not duplicated. So if one of our denominators has r plus 1 and the other denominator has r plus 1 and r minus 1, then our LCD will be r plus 1, r minus 1. That way it's got all of the factors from each of the denominators and none of them are duplicated. Okay, so that is what we are going to distribute through our equation. So we're going to take our equation and we're going to multiply it through by r plus 1, r minus 1. Now when we take this LCD and we distribute it to the left side of the equation, what's going to happen, I'm just going to show this real quick as an intermediate step because most of the time you don't have to show this. What's going to happen is this. The r plus 1 and the r minus 1, they technically become part of the numerator. But what we're doing is we're multiplying something to the numerator that will then cancel out the denominator because this r plus 1 and r minus 1 are the two factors for that denominator. So all that would be left of this left side of the equation is this r squared plus 1. Okay? And so like I said, normally we don't show that intermediate step. Normally what a lot of people just do mentally is when they distribute this to the left side of the equation, they simply mentally go, okay, this denominator is going to cancel out with these two factors. And all that would be left would be the r squared plus 1. Okay? But then they have to repeat that process mentally because we haven't taken the r plus 1 and r minus 1 and distributed it to the right side of the equation yet. When we distribute it to the right side of the equation, this r plus 1 down here will cancel out with this r plus 1 that would be going to the numerator. And so what would be left would be the 5 that was already in the numerator and the r minus 1 that we have put into the numerator. And so what we have done is we have eliminated the fractions. You guys, it seems really foreign and it's certainly a level of difficulty higher, but when we were doing linear equations at the very beginning of the year, if I had a linear equation that said, 2/3 x minus 3/2 y is equal to 4, I would have taken that entire equation and multiplied it through by 6 to eliminate the fractions. Okay, and that is what we are doing. Okay, so we are just doing it with more difficult equations to eliminate variables instead of just numbers. Okay, so now what we have is we have just a quadratic equation. It is no longer rational, and since it is quadratic, we need to simplify it and get it set equal to 0 so that we can solve it. So the left side is already simplified for right now. I need to distribute the 5 through the parentheses and get 5r minus 5 on the right side. And now I want to move everything to one side because this will be a factorable quadratic. So I'm going to subtract the 5r to move it to the left side. And I'm going to add the 5 to move it to the left side. And so this is what it yields. I'm left with r squared minus 5r plus 6. And that does factor. It is a factorable quadratic. It factors as r minus 2, r minus 3. And so I yield r equals 2 as my first answer, r equals 3 as my second answer. Neither one of them was an excluded value, so I don't have to worry about throwing either of those solutions out. Okay, so now the second example. Okay, so for example 2, this one is not already a proportion. So of course you have the option of working through it the same way we did on day 1 of this week. You could combine the left side to become a single fraction and turn it into a proportion, but we're going to do this alternate method with it as well. So of course the first thing that we look at is we look at our excluded values. So the first fraction in the equation would generate an excluded value of 0, because when x is 0, that denominator would be 0. and the second fraction in the equation generates an excluded value of -1. So we keep that in mind as we are solving. Then the next thing that we figure out is what is our LCD, because that will be what we distribute through by. And so because we only have two fractions in the equation and the two denominators have no common factors with each other, our LCD would be the result of multiplying those two denominators together. So our LCD is going to be x times x plus 1. Okay, so we're going to switch colors, and we're going to distribute through by our LCD, which is x times x plus 1. So when I take that LCD and distribute to the first part of my equation, what happens is the x in the denominator would cancel with this x right here. And so what would be left would be the 200 and the x plus 1. Now when I take my LCD and I distribute it to the second part of the equation, that's just the -10 right there. And there is no denominator to that term, which means there's nothing that will cancel out. So the -10 is going to stay, the x will stay, it won't cancel out with anything, and the x plus 1 would also stay. And then when I distribute to the final part of the equation, which is the right side of the equation, what happens is the x plus 1 right here would cancel out with the x plus 1 right there. And what would be left would be the 200 and the x. Okay, so what that means I'm left with is an equation with no more fractions. It will ultimately become a quadratic again. Okay, so what I need to do to figure that out is I need to simplify, distribute, start combining like terms, and see what it becomes. So I take the 200 and distribute through that first set of parentheses, and I get 200x plus 200. Take the -10x and distribute it through the second set of parentheses, and I would get minus 10x squared minus 10x. And then on the right side of the equation, I just have the 200 and x. There's nothing to distribute. And so now you can see that it's going to become a quadratic. The numbers look kind of big in it, but don't panic, because one of the first things that would happen is the 200x's are going to end up canceling out when you try to move everything to one side. So as you begin to move everything to one side, those 200x's cancel, and you end up with 10x squared plus 10x minus 200. Now I did that by moving everything to the right side. You could leave everything on the left side and then simply distribute a negative through to eliminate those negatives. Either way is fine. But what you end up with is you end up with a quadratic where every term in the equation is divisible by something. In this case, every term in my equation is divisible by 10. So I divide through by 10 to reduce the equation down, which makes it substantially easier to solve. Okay, so when I divide by 10, my first term becomes x squared. My second term just becomes an x, and my third term just becomes a 20. And so now it's a much more manageable equation. Okay, so now I can factor it. And so when I factor it, I get x plus 5 and x minus 4. And so I generate two answers. I get -5 as my first answer. I get positive 4 as my second answer. Neither one of those is an excluded value, so I don't have to worry about excluding or throwing it out. Excuse me. Okay. And now we can apply these skills to a word problem. Okay? So when we give you guys a word problem, we will be providing you with the equations. We simply want you to practice solving. So this is how these kinds of problems will set up. So let's say you have a varsity choir that's going to take a trip to SeaWorld and they have to rent a bus for $500. Then if X is the number of varsity choir members and Y is the price that they have to charge per person to pay for the bus, then your equation would say that if you took the $500 cost of the bus and divided it among the X varsity choir members, it would be equal to Y, the price per person. So that's the original equation. But then it says at the last minute, 10 JV choir members were invited to attend the trip. And so what that means is now the $500 for the cost of the bus is now going to be divided among X plus 10 people. It's X varsity choir members plus the 10 JV choir members that were invited to go along. And the result is that the original cost, which was Y, is now going to be decreased or reduced by $2.50. And so what we have just generated is a system of equations. And that sounds like it's quite a bit harder, but it's not going to stay a system for very long. So what we're going to do is we have our original equation and we have our new equation. And step one is simply to substitute. I'm going to take this original equation and I'm going to substitute it right in there for Y. And so what that gives me is it gives me a new equation. And so this is actually the equation we are going to solve. Okay? And so we're going to solve it the same way we just did example 2. It's almost an identical scenario. So, of course, our excluded values. So I'm going to do that up here. Our excluded values would be 0 and negative 10. And our LCD that we're going to distribute through by is X times X plus 10. Okay, so like I said, very, very similar to the second example. So I'm going to take my entire equation, distribute through by X times X plus 10. When I take that LCD and distribute to the left side of the equation, the X plus 10s would cancel, and we would have the 500 times X. When I distribute to the first part of the right side of the equation, this X would cancel out with this X, and so we would be left with the 500 and the X plus 10. And when we distribute to the final part of the right side, there's no denominator here, so nothing is going to cancel out with either of these two factors in our LCD. So that means we will keep the 250, the X, and the X plus 10. So we've eliminated the fractions. It is, of course, going to become a quadratic again, just like example 2. So the left side is already simplified, nothing to do with it for right now. The right side, when we distribute through this set of parentheses right here, we get 500x plus 5,000. And then when we take this and distribute through its parentheses, we get minus 2.5x squared minus 25x. And so once again, I'm going to move everything to the other side of the equation, because what that will succeed in doing is it will cancel the 500x's out, and it will make my quadratic positive. So if I move everything to the other side, I would have 2.5x squared, it's now positive, plus 25x minus 5,000. And it's all on one side, so it's set equal to 0 now. Once again, the numbers in these equations look scary. They look prohibitively large. But I'm going to take that equation and everything in it is divisible by 2.5. I'm going to divide everything in it and reduce the equation down. When I reduce the equation down and divide everything by 2.5, the first term just becomes x squared. The second term just becomes 10x. And the third term, when you divide it by 2.5, just becomes 2,000. Which still seems really large, but with a middle term of 10x, so if I have x squared plus 10x minus 2,000, it's pretty easy to factor the 2,000 to generate a 10 in the middle. This factors as x plus 50, x minus 40. And so this factor would give us a solution of x equals negative 50, and this factor would give us a solution of x equals positive 40. But remember what x represents. X is the number of varsity choir members. And so even though we've generated these two answers, this answer doesn't make sense in the real world. You can't have a negative number of choir members. And so x equals 40 is your solution. But now what we want to do is we want to interpret that solution in the context of the real world. So what that's telling us is that there are 40 varsity choir members. Okay? And then they asked us to figure out the cost per person in the problem. Well, technically there's two costs. There's the original cost per person, and there's the new cost per person with the 10 JV members now riding the bus too. And so if the bus was $500 and you divide it by the 40 varsity choir members, what you figure out, so at that point all you're doing is the 500 divided by the original people, and you figure out that their cost per person was $12.50. The new cost per person, you could do it a couple ways. The word problem said the cost decreased $2.50 a person, but if you want to check your work, what you would figure out is you would figure out, okay, well, there were 40 people going, now there are 50 people going. If you did $500 divided by the 50 people who are now going, sure enough, you confirm that the new cost per person is $10, which is $2.50 less than the original cost. So all of this is the information you were able to figure out by solving that rational equation. Okay? So these are the 3 practice problems that I would suggest that you try. I have already set up the equations for the word problem for you, but if you want to take some time, copy these down and give these a shot, then you can check your answers before you move on to the learning check for the week. Thanks, you guys.